Well, thank you very much for joining me today. What I'd like to do in this brief video is to demonstrate the Flex Rigid capability within Altium Designer and to walk you through the actual process in creating one. So what I'm going to demonstrate on is a tetrahedron. So you can see it right here. I'm currently in Altium Designer 14. That's when they first introduced the Flex Rigid. And I'm in the 3D mode. So just to kind of give you a very brief overview of what I'm going to do, I'm going to click on my PCB panel. Right, and in the PCB panel, you're going to see a new sub-region, or basically a sub-panel called Layer Stack Regions. And over here, I'm going to do the fold state. So I know I'm jumping to the end here, but I want to give you a preview of what we're doing, and then you'll be able to do this here once you're done viewing this video. So in the fold state here, I'm going to create a tetrahedron. All right, if I hold down my Shift key, you can see that I've got that over here. Okay, so the best way for me to demonstrate this is to open up a new PCB and to go through the motions, and that's what I'm going to do here. So before I go anywhere else, I'm going to go to hit my 2 key in 2 dimensions so you can see what I've got over here. We're going to do some copy and paste. We're going to use the 2 of the mechanical layers here in order to recreate this in my new project, or actually in this case just a new PCB dock. So I don't need to actually have a project to do this, though of course it's always good to have a project, especially if you're working with schematics. But for this demonstration, I simply need to have a PCB dock. So I'm going to go into File, New, PCB dock, and I'm going to open one up. And you can see that this is your standard 4x6 inch board, pretty much the way you would always see it in any Altium Designer version that you've got. Now the very first thing we're going to do over here is we're going to deal with the layers, because that's the big thing that Altium had to change in order to make this Flex Rigid to work. So what I'm going to do is I'm going to go into Design and Layer Stack Manager, and you're going to see that the dialog is completely changed. Now by default it's basically showing you a rigid board, but if you need to do a Flex Rigid, you can hit the Advanced button over here and you can start creating different regions. So for example, if you have a board, and let's say the centerpiece has 8 layers and the Flex Rigid has 2 layers, and the peripheral boards that are going to connect to those Flex Rigid are 4 layers, you can actually define each one of those. This would be, for example, your main stack, your flex stack, and another rigid stack here. All right. Now I'm not going to go through the motions of that. I believe that warrants probably a video all its own. But what I'm going to do here is I'm actually going to load in an existing stack up that came from one of Altium's examples. So what I'm going to talk about just very briefly is where it came from. So what I've done over here is I've actually navigated to over where Altium Designer has its examples in my machine. And for Altium Designer 14, they added 2 key examples that you may want to take a look at. One of them is the Bluetooth Sentinel, and the other one's the connected cube. Okay. Now, the Bluetooth Sentinel is the one that you'll see in most of the videos if you go to Altium.com. The connected cube, I haven't seen too many videos, but it's just as good to take a look at that one, because it gives another very good example of how you can do the Flex Rigid. And in fact, for the stack up, I am borrowing the one from the connected cube. So prior to this demo, what I did was I went into the connected cube and I saved out, which is what you can see over here, I saved out the stack up, and that's the one I'm going to be pulling in now. So let me move this off to the side here, and let's go over here to load. And you can see over here I now have my stack up, connected underscore cube, and I'm going to bring it in. So I'm going to open it up, and now you can see this has changed because it's pulled in that information. So this is good to go at this point in time. Now you can see there's been no changes here to the board because we still haven't really defined anything, and that's what we're going to do now. So the first thing I'm going to do here is I'm going to change my grid. I'm going to hit the G key, and I'm going to change the grid to 10 mils. Now I'm going to, the other thing I'm going to do before I jump over and start copying and pasting things, I want to turn off a few layers because I got a lot of stuff going on over here and I really don't need most of them for this demonstration. So I'm going to hit my L key and I'm going to turn off all my paste and solder layers. I'm going to turn off all my silks, and I'm also only going to keep 2 of my mechanical layers. I don't need to have 3 of them. So one of them is going to be my board and the other one's going to be the lines that I'll use in order to draw my sections. I'm also going to turn off the drill guide, the keep out layer, and the drill drawing. However, I have to leave on the multi-layer, and also will need to leave on these layers. Even though I'm not really doing anything with these from a copper perspective, I need to leave these on in order for me to select the regions I'm working with when I go into what they call the board configuration mode, or the board view mode, which I'll describe in a few minutes. It's a new way to view boards in Altium Designer 14. So I'm going to press OK, and that should clean this up over here, and that's just fine with me. So the first one I'm going to deal with is mechanical layer 13, and actually I'll save this very quickly just to make sure we're good on that. right? And I'll save it as example. Now that we have this saved, I'm going to go over here to the PCB, the one that we have originally, and I'm going to go over to the mechanical layer 13. I'm going to sweep over this to copy it. Okay, standard copy and paste. And of course, in the PCB document, when you do a copy, it wants a point of reference, and that's so I'm going to take the summit up here, click on that. I'm going to bring that one down here, and I'm going to do a Control V, and I'll paste it down. Okay, and actually, let me jump up here. One thing that's very important is to make sure that this is on grid when it does get pasted down. Control Z. Let's do a Control Z again to remove it. And when we do a Control V, let's make sure we get this on grid. And the reason why it's important is because when we start putting the lines down to declare the sections, if those lines are not sitting on a grid, you'll get a crisscross, and those crisscrosses can result in additional regions that you weren't intending. So that's what we're going to try to avoid over here. So we've got this here, and before we go any further, let's just kind of clean this up very quickly. I want to basically make, since this is my board outline, what I'm going to do here is I'm just going to clear the board outline. So I'm going to go into design, my board shape, and I'm going to define from selected objects. And so now my board shape is all set to go. What I'm going to do now is I'm going to jump back here and go to my mechanical layer 15. And my mechanical layer 15 is basically the triangles that I drew initially in order to make this work. So I drew one of them, so I made sure that this was set up correctly so that these are isosceles triangles. I took one and then I would copy it over and I moved them in such a way that there would be a flex region between each one of them. Okay. And by the way, this is the kind of planning that you really want to do doing this, because Altium is not very forgiving right now if you need to make changes to this later on. So if you're going to do something like this, I would highly recommend that you do this in a CAD tool, especially something like SolidWorks or any other CAD tool out there, to make sure that this is correct and then import it in. If you don't do that and you got to make some changes, it gets very tricky in that regards, because Altium doesn't allow you to easily just change a section in terms of its shape, and even changing a line over here can result in it basically saying, I don't know how to define this section, redefine it for me. So just be aware of that. But for now, it's all defined. I'm going to do a Control C, and I'm going to again copy it here at the summit point for my point of reference. I'm going to do a Control V, and actually before I do anything else, let's go to Mechanical 7, and just to be on the safe side here, I'm going to do an edit, a paste special, and I'm going to say paste on current layer just to make sure it does go onto the current layer. I'm going to zoom it in by hitting my page up key. Looks like I'm on the summit, and now I should be good. So if I do a view fit, I can now see that I've got this on here. Alright, now that I've got this set up, and again I'm going to do a save. I'm keen on saving in Altium Designer. So the next step that I need to take now is I need to start adding in my regions, because right now Altium doesn't know that these are all different regions, or that's my intention of having different regions. And in order to do that, we need to look at a new mode that Altium added in. So where my cursor is on the top, we have what's called the view, which is the view menu, and we have something now called the board planning mode. And I called it the board configuration mode, but I was referring to this. And in the past, we've always had the 2D mode and the 3D mode. So we'd hit the 2 key to be in 2D, and we'd hit the 3 key to be in the 3D. But now you can hit the 1 key to get into the board planning mode. And if we go to the board planning mode, you'll notice that the place menu just above my cursor tip is going to disappear, because we don't put copper in this mode. This is strictly to deal with things on the board level. Okay. So now that we've got this up and running over here, I can start defining my board. So I'm going to go again to my PCB panel, okay, and again layer stack region, and I'll drop this down so you can see this is something, the PCB panel's been here for many years. However, they just recently added in the layer stack region, and that's what we're going to take a look at over here. So it shows me my board stack up here. So this is strictly the stack. It's not telling me the number of sections I've got. And that could be a little bit deceiving, because when I first looked at this and said, wait a minute, I've got 7 sections I'm going to create, and I'm not counting 7 here, I'm seeing different numbers. Well, again, that's because these are all the stacks that they refer to in the Layer Stack Manager. What I'm most interested in right now is the stack up region here, and by default, Altium's saying, look, you got 1 region. So I need to start breaking these up, and the way I do that is I go into Design, and I do something called Define Split Lines. Okay, so when I do this, I'm going to draw them in. I'm going to kind of do them a little bit hastily, because one of the things I found is that you don't really start at the edge here. You can click on the edge, but it won't do anything. You really need to click on the board, and then it jumps its initial point to the side, and then you just move the other one as such. And I just find it easier just to throw them down and then to move them afterwards. So I'm going to have to do this again a couple more times. Unfortunately, there's not a step and repeat function in there at this time. It's probably something they'll add in as they continue to improve upon this. It's a relatively new thing, and I think they did a phenomenal job of it. And like anything else, over time people will ask for these enhancements, and Altium will oblige. So we will go over here and just throw these in, and then we'll fix them up in a moment. Okay, so now that I've got these in here, we just need to do a little bit of a repair on these, make sure that they're all sitting nice. Okay, and the horizontal ones aren't too bad. Now, I mentioned earlier, and you can see kind of over here, I'm going to page up, it's really important that these split lines sit on a grid, because if they don't and they crisscross over here, Altium will actually recognize that tiny area past the crisscross as another region, and that can have an impact. And as I mentioned earlier, if you try to remove that, it gets a little sticky, because once you move it, then Altium's like saying, well, I really don't understand where you want this region, and it'll kind of back off. And as a result, you would have to redefine it again. Now in this case, it's not too bad, but if you got a lot of bend points, you really want to make sure that's done right the first time, because it can get a little messy. So let me go over here and we'll move these up. All right, and let's page up here. And we'll push these up here. And we'll view fit. So when I do my view fit, I hit the letter V followed by the letter F. And I'm using my page up key here just to jump around, just to kind of give you a quick reminder that when you're doing these panning and zoomings, especially the panning, if you hit the page up and page down on your computer, it's going to page up it's going to pan based on where your cursor is. Now you can see right there that I just crossed it, and if I don't fix that, that could be a problem. So let's make sure we get that right. Alright, so we've got those down. Let's do a view fit. And if we go over here, this is our sanity check. So there should be 7 regions now. So we should have 4 rigid. So we've got top, or what I've been calling up, down, left, and right. So that's 4 of them, and our soon-to-be flex regions is 3 of them. So if we count this, we have 1, 2, 3, 4, 5, 6, and 7. Altium wasn't very creative in its names over here, so we'll have to take care of that on our own. But this looks good to go. So what I'm going to do now is I'm going to click on each one of these, and I'm going to give them a name, and I'll declare them as to whether they're flex or they're rigid. Now you'll notice that when I do this over here, double click on it, sometimes it does not work, and if that's the case, you want to make sure you're on the top layer, and that will make sure that it works. Also, as I mentioned earlier, you got to leave the multi-layer on. If you don't leave the multi-layer on, you won't be able to select these. Alright, so those are the 2 things, just little caveats just to keep in mind. But I was able to select this here, and I'm going to change its name. I'm going to call this up. Okay, I know it's not very technical, but it allows me to see where I am with things. And layer stack is the board layer stack, which was declared to be rigid in my layer stack manager, and that's all I'm going to do with that. And I'm going to repeat each one of these here. So this one I'll call down. Now the difference here is I'm going to lock this one down. What the 3D lock means is that this is the one that's not going to move. So when I create that tetrahedron by moving the fold state over here, they're all going to come together, but this is the one that's going to stay stationary. So that's the 3D lock. I'm going to press OK. I'll call this one left. Call this one right. So we've got those now set. Now let's take care of the flexes. So I'm going to double click in this region here. And the way I've been doing the flex, just as a naming convention, is that if I have a flex, it's basically acting as a cable or a connection between the 2 rigids. So here I've been saying like up to down. Okay, and since my down is my locked position, I'm giving everything a reference to the down. And then in addition to this, I got to declare it to be a flex. And since this was declared as a flex in the layer stack manager, I can see that they've already given me basically a bend line, which we'll talk about in just a minute. So I'm going to double click here and kind of do the same thing. We're going to go left to down. Again, I'm going to change this to flex. And I'm going to go over here and I'm going to do right to down. And I forgot to change this to flex, and now we've got it. Okay, so now we're good. We have all of them defined. And you can see that over here. You see the names have been changed. A lot easier to read. And if I click on any of these, sometimes it'll zoom in on it. Sometimes it just it'll highlight it. In this case, it's not. But that's fine. You can see me do it over here, and that works just as well. All right, now what I'm going to do is I'm going to page up, and I'm going to start moving my bend lines. The bend lines are important because that's ultimately going to tell Altium how to do the fold. And if you have a flex area, you'll also notice that Altium's added the bend line here and a default radius based on what you've got over here in terms of the amount of flex that you've got. And also it gives you a sequence. So the sequence over here allows you to put things in order. So when you first saw the one that I was demonstrating at the very beginning of this demonstration, I had the sequences 0, so as a result they all folded at the same time. But if you wanted to have one fold at one after another, you can change one to have the sequence 0, another one to have a sequence 1, the other one to have sequence 2. Okay? So right now we're going to leave them all like this so that we can, so when I show the fold state, they'll all come up at the same time. What I need to do right now is I need to change these bend lines. So those golden lines here, I need to start moving. And I'll move those over here. Now, I don't like where they are. I'd like to prefer to have them in the center. So in order for me to do that, I need to change my grid. So I'm going to hit the G key here, and I'm going to go to 5 mils. Okay. Again, I'm going to click on my line, and I'm going to bring that up. I'm going to pan over by holding my right mouse key. Okay. And now that one's fixed. These over here are a little bit stranger, but that's fine. We can fix those pretty quick. And we'll put those, and again, it's because of my grid here. It may be off a little bit, but that's fine for what I need. And here's my line here. I need to get that one. So that should be all right. And then let's go here. Same thing with this one. Okay. And I'll pull this one here. And I suppose that if I went to 1 mil, I could get this really dead on. But keep in mind, in the real world, this flex isn't going to perfectly bend it. It's not going to be perfectly bent in the middle. It's going to depend on the manufacturing processes. But this should be good enough to get us what we need to view at this point. I'm going to do a VF, and you can see it here. Now it's all set to go at this point. So if I hit the 3 key, that puts me into the 3D mode. I'm going to make one quick change here. I'm going to hit my L key, and I'm going to go to the 3D Altium Blue. It's a little easier on the eyes. So we've got that here. I'm going to do one step. I'm going to do a page step down. So I've got that here. And now I'm going to try the fold state. And so as I'm pulling this along, we're getting it, everything's looking great, and then we stop. So what happened here? Well, keep in mind that my flex was set to 90 on each one of these. Okay? And that's where it's going to stop. But a tetrahedron doesn't have a 90-degree bend. It actually has a 109.5-degree bend. And no, I don't remember that from my geometry days. That's just something I looked up prior to doing this video. When I originally saw this, what's going on, and I had to do some investigation of it. So how do we change that? Well, if I click over here, I can change that as such, 9.5. And just to save a little time, I'll copy that for the next couple. And then right to down, same thing. And left to down, same thing. Okay, so you've got this over here. Now, again, this is what's really important about doing these things before time, because you can see that these are overlapping each other. And if these had components on them, the component clearances would violate. Okay, so it's really important that when you draw these things out, that you give a lot of thought and time to how the flex and how long the flex is going to be, where do you really want it, and to make sure that it's going to work. For our sake over here, it's worked out pretty good, but from a manufacturing and realistic point of view, you wouldn't have a board of this nature because you've got overlap. So the last thing I want to talk to you about are the bend radiuses. So Altium by default will provide a bend radius for you over here, and the larger the bend radius is, the wider it's going to kind of pull out over here. So you can exaggerate it by putting 1, and that's what I'll demonstrate right now. So if I hit the radius here and I put in a 1, okay, you'll see now that this has a very sharp bend, which is very unrealistic. You would never want to do this to a flex because you're now putting a tremendous amount of stress on the copper, and if it didn't crack already, it will in short order. So, but be realistic about these bend radiuses, and just to demonstrate the extreme opposite end of it, if we go over here, let's say that we had a radius of 80, okay, and we press OK, you can see this gets kind of pushed up because the radius is really starting slow up here. Okay, so I think this one was at about 35. I'll put that back just to kind of clean it up a little bit. So that's the feature of the tool, and I recommend that you take a look at the examples that Altium Designer has provided and to play with it, and to definitely provide feedback to Altium, because they'll definitely want to improve this. It's a great innovation that they've added to the tool, and I think that a lot of people will find it very useful. Well, thank you very much for your time, and good luck in your endeavors.